So adding and subtracting polynomials is almost the same as simplifying an expression. By the way, speaking of simplifying expressions, most students do not know what it means to simplify. They might know what it means to simplify a fraction because that's what it was that they were told it meant, or what they were told simplification in reference to. But simplifying just means to combine all terms, multiply all terms, divide all terms in an expression until there's nothing left to simplify, nothing left to combine, multiply, divide. Here's a very simple example. Over here, let me get a pen. I'll use purple. So let's say we had 3 plus 6 plus 2. If I want to simplify that, I would have to add these two terms, or these two terms, and then the other two terms. So, and I can add them in either order, because that's the associative property of addition. I can add this. If I put parentheses around here, I can do this addition first, or I can put parentheses around here and do this addition first. So let's say we do it this way. We get 9 plus 2. And that is a simplified expression, an equivalent expression. They have the same value. So these are equivalent, but this is not fully simplified. It's more simple than this, but it's not simplified. If this was an 11, this is now in, I suppose we'd have to call it simplest form. Okay? So that's a value in simplest form. We get the eraser. Alright, so we erase everything. Tap for gone. Alright, so this is the smartboard software, so same stuff you'll see in class. So to simplify an expression, we start off by multiplying where we can, and that usually means distribution in this case, so we get 3x to the third. That's nothing to change. We're going to multiply the negative 6. This is not minus 6, it's negative 6. It's really plus minus 6. As far as I'm concerned, there's no such thing as subtraction. We're just adding a negative number, so this is really a negative 6. So it's negative 6 times 2x, which is 2x to the third, which is negative 12x to the third. Then we have negative 6 times negative 6, which is a positive. Two negatives make a positive. Positive 36. The 3 is by itself. This is where people make mistakes, though. They think they're supposed to distribute the 3 into these. But the 3 is not next to this. This minus is next to this. And like we mentioned before, if there's no number here, it's really a 1. So it's negative 1 times 10x to the third plus 5. So that's negative 10x to the third minus 5. Minus 1 times 10 is negative 10, and minus 1 times 5 is negative 5. So this is now an equivalent expression. It's not a fully simplified expression, though, because things can still be combined. So looking at the like terms, we have the 3x to the third, the negative 12x to the third, and the negative 10x to the third. So we're just going to add all of those up. So 3 minus 12 is minus 9. Minus 10 would be minus 19. X to the third, as again we don't mess around with the exponents when combining like terms. The other like terms we have would be the 36, the 3, and the negative 5. If you put all of those together, and we get, that's 39, take away 5, that is 34. So this is our simplified expression. So that can't be simplified any further because negative 19x to the third and positive 34 are not like terms. So this is as much as can be simplified. Alright, let's take a look at polynomials to be added or subtracted. I have some Regents questions here for you, old ones. Let's see if the page will change. Clicked it. There we go. Alright, so how do we add and subtract polynomials? The first one is adding polynomials is very straightforward. Add the two polynomials. Now, what people seem to ignore in these problems is that there are parentheses here, and they actually do matter. Maybe not as much in addition problems, but they matter a lot when it comes to subtraction problems. So, if we wanted to combine these, we could just add the like terms. But it's not like we can just add the like terms. There's a reason we can do that, and that's because this set of parentheses has no number here. So it's sort of like having a a 1 there. Why is it writing? A purple pen. Alright, so there's like a 1 here, and it's like there's a 1 here. So we distribute. This is going to stay the same, because what happens when you multiply by 1? A number does not change its value when multiplied by 1. 1 times any number is that number. Same thing here. So that's minus 12 plus 5x plus 6x squared. Again, we combine the like terms, so the 5 goes with the negative 12. I'm actually going to put that on the end because there's something called convention, and convention is the way that people choose to do things so that everybody does it the same way. And in mathematics, we have the order of operations and other things that have to be done a certain way so that everybody reads things the same way. So when it comes to writing a polynomial, we normally write it from highest exponent to lowest exponent. So that should really go last. We have 7x to the third. I don't see any other x to the thirds, so that's also the highest degree, so that's going to go all the way over here. Then we have the 3x squared, which combines with the 6x squared, and since they're both positive, that's 3 plus 6, which is 9x squared. And we have this 5x by itself, so there should be a 5x here. So this is its simplified expression that results from adding these two polynomials. Now the next one is a word problem, and the reason it is a word problem is because this is a little trickier than it actually looks. It looks super simple, but it's not nearly that simple, because when you're adding two terms, you need to put them in parentheses, because in some cases it will matter. In this case it's not going to matter, but you do need to get used to it. The sum of two terms says to add them, so we're going to put them in parentheses and add. Okay. And since we're just distributing by 1, these are going to stay the same. We can just combine the like terms. So 4m to the fourth and 1m to the fourth, again if there's no number is a 1, is 5m to the fourth. We have minus 1, negative 1, m squared plus 5m squared, which is minus 1 plus 4, which is, plus 5, which is 4. 4m squared. And again, I wrote it with the highest exponent first, the other exponent second. So this would be the sum of those two polynomials. And the parentheses are significantly more important when you're subtracting. So we're going to look at some subtraction problems in a moment. Addition problems are very straightforward, just essentially combining like terms. Alright, so let's go over here. Alright, so I actually use the exact same problems, but they are rewritten. And subtraction does cause differences, so we gotta get used to that. Again, there's essentially a 1 here, and there should be a 1 here, and this is where everybody makes a mistake. They just take them out of the parentheses, because in addition problems you can. But I don't recommend you do that. I recommend you understand it. If you understand it, you're really supposed to be distributing. 1 times this is going to stay the same, so that's 5 plus 7x to the third plus 3x squared minus, we're actually going to distribute the negative 1. So this is negative 1 times negative 12, negative 1 times 5x, and then negative 1 times 6x squared. So that will become, two negatives make a positive, so that is positive 12. Negative positive, that will be negative 5x, and negative positive, that will be negative 6x squared. Okay. Some people notice that when you distribute a negative 1, the sign of all the numbers just changes. But that makes sense, because any number times a negative will change its sign, and times a negative will not change its value, so its sign will change. So let's combine the like terms. Let's just start with the big ones first. So the 7x to the third is by itself. Where are we? The 3x squared minus 6x squared would be negative 3x squared. So that's this and that. Then we have the, did I miss something? Something looks weird. Is there a regular x term? Here it is. Now it's negative 5x. And then the 5 and the 12 in this case become 17. Alright. Now the trick problem. This is the one that everyone messes up. Everybody messes this up. I've messed it up. I've taken this Regents before. think I took this from the region I took. What is 4m to the fourth minus m to the second subtracted from 5m to the second plus m to the fourth? And now let's take a look at what happens. Two things happen. One, someone writes this, 4m to the fourth minus m squared. For this one they write 5m squared plus m to the fourth, and then they write a minus between them, and this is actually set up incorrectly. It should be written the other way. This really belongs here, and this really belongs here. And then I know what you're thinking, but Mr. Gottlieb, this one comes first in the problem. And just because something comes first doesn't mean that it means it that way. So let's take a look and try to see if we can figure out why it should really be written this way. And the way that I find that's easiest to do is to replace this with a number and replace that with a number, and let's see if it makes any more sense. So here's the same problem, but instead of 4m to the fourth minus 2m, m squared, we replaced it with 2, and instead of 5m squared plus 4m to the fourth, we replaced it with 5. So what is 2 subtracted from 5? Now, if you use your imagination, I would think to take 2 away from 5 would leave me with 3, which really means 5 minus 3, meaning this, based on how this statement is written, it's the first thing is being taken away from the second thing. That is why it's written in this order. So this is really the same thing as 5 minus 2, which is why this is the way it is. Another one that comes up quite often, which is probably the most confusing English issue that people have with mathematics, is this. What is 3 less than 5? So that again would say you're going to take the 3 from 5. 3 less than means to take 3 from something. So if this problem was actually written as what is 4m to the fourth minus m squared less than 5m squared plus m to the fourth, would also be written this way. Okay? So those are just two examples that if you wrote them with real numbers, they make a bit more sense on how to set them up. So again, there's supposed to be a 1 here, and there's supposed to be a 1 here. And generally in these types of problems, there's always a 1 to distribute. Sometimes it's negative. So that is 5m squared plus m to the fourth minus 4m to the fourth plus m squared. Combine like terms, 5m to the second and m to the second is 6m to the second, and m to the fourth minus 4m to the fourth is minus 3m to the fourth. And this is probably not the answer I'm going to see on the Regents in the multiple choice section. I would probably see this one, minus 3m to the fourth plus 6m squared, because convention says we write the highest exponent first. So while both of these are equivalent expressions, we would normally write it the other way.